Hello students, I will now show you how to devise net reactions. Oh, that says runs again, that should say reaction. Hello students, I will now show you how to devise net reactions with and without oxidation numbers. Okay, so with oxidation numbers, so the difference between what I showed you last time and what I'm showing you now is last time we were doing half reactions. This time we're doing net reactions. When I show you the second method, that makes a little bit more sense, but here we go. So, balance the atoms that are not O's and H's. That step's kind of the same. I got two CRs on one side, so make two on the other. I don't care about H's and O's. I got one N, done. Assign oxidation numbers, okay? So, after I've assigned my oxidation numbers, I don't know why I didn't show them all there, but these are the ones I care about now. So hopefully you get the same answers I did there, but like the O is a -2, and it has to come out to -2. I got 7 of them, -14, so CR2, that has to be a +6. But anyway, I think you're good at that now. So, assign oxidation numbers. So what? Well, let's look at chromium. Chromium's going from a 6 to a 3, which means we're gaining 3 electrons per atom. There's 2 atoms. Total, I'm gaining 6 electrons. Let's look at nitrogen. Nitrogen's going from a 3 to a 5. If the number goes up, I've lost 2 electrons. Okay? Now, the next part is, this is new. Because I'm dealing with both sides of this reaction, or what I mean, both halves of the reaction, I got one substance losing electrons, the other substance gaining electrons. My electrons have to be balanced. I use the tennis analogy. If I hit 2 tennis balls, the other side's got to receive 2 tennis balls. So if you look at what's happening here, nitrogen is throwing away 2 tennis balls, but chromium's gaining 6. Well, that doesn't make sense. You can't throw away 2 and have the other guy get 6 all of a sudden. So I'm going to multiply that by 3 to make it 6. Now my electrons are balanced. I trace my little arc back to N. It's actually N that I'm multiplying by 3. So I put a 3 in front of HNO2, and that means I've got 3 N's on the reactant side, so I need 3 N's on the product side. All right, and now I finish. I add water to balance O's. So on the left, I've got 7 O's and another 6 O's, so that's 13 O's. And on the right, I've got 9. So I need to add 4 waters over there to make it 13 O's. Okay, and now I've got 8 H's over here. 2 times 4 is 8 H's for water. On the reactant side, I've got 3 H's in HNO2. So I need to add 5 more to make 8. So there I've added my 5 H positives, and there, now I have a balanced equation. I can check the net charge. I got a +3 on that side because I got 5 positives, 2 negatives, and a 0, so +3. And on the product side, I got 2 CR3 positives, so that's 6 positives, 3 nitrates, and they're each negative, so 6 minus 3 gives me +3. Okay, so that's how you balance. So there's my answer. That is my balanced redox reaction. Now I'll show you quickly how to do this without oxidation numbers, and it sort of almost explains what's actually going on here. I don't like this method because it takes way longer, and you don't know if you know oxidation numbers or not, right? Like if you don't use oxidation numbers, you don't know if you actually know them. So I don't prefer this method, but I'll show it to you because it's good at explaining. Okay, so I'm going to balance the atoms that are not O's and H's. So I got my chromiums balanced now. My N's are already balanced. I don't care about H's and O's. Okay, now I'm going to separate this into its 2 halves. I kind of have a chromium half and a nitrogen half. So there's my chromium half reaction, and there's my nitrogen half reaction. Now let's just build the nitrogen one. We'll devise the nitrogen reaction without oxidation numbers. So I'm going to use all these steps: add water, add H positive, check the net charge, add electrons. So HNO2, I got 2 O's and 3 O's, so I got to put a water over there. Now I got 2 H's plus that one more. That's 3 H's over there. Now check the net charge. On that side, I got water and that acid, so that's 0. There's no charge. And I got a -1 and a +3 on the other side, so I'm at +2. So I've got to put a -2 on this side, 2 electrons, and that makes it come out to 0 and 0. And that matches what I had on the previous page, right? Nitrogen was throwing away 2 electrons. Okay, let's build this half reaction. 7 O's, 7 waters, 14 H's, 14 H's. Net charge, +12, +6. I got to add 6 electrons. So now I gained 6 electrons. So I'm throwing away 2, gaining 6. So I've got to multiply the top reaction by 3 so that I get 6 electrons, and those electrons cancel because they're on both sides of the equation. Look what else cancels. 3 waters cancel out 7 waters, leaving me with 4. And 3 H's cancel out, 9 H's, because I have 3 times 3 is 9. 9 H's cancel out 9 H's, so 14 becomes 5 H's. And then I can add everything together, everything that's on the reactant side. 3 HNO2s, 5 H positives, and a Cr2O72 negative produces 3 NO3 negatives, 2 Cr3 positives, and 4 waters. And there is your balanced equation with +3 on that side, +3 on that side. Okay, I prefer you to use the oxidation number method, but that sort of explains what's actually going on. The top reaction is an oxidation reaction, throwing away electrons, which must balance with the electrons in the bottom equation, the reduction equation. And then just like we did in grade 11, then we have to figure out our net reaction by adding everything all together. Okay? And canceling out whatever is on both sides of the equation. All right, there you go. That's how you build net reactions in Redox.